I'm from the Netherlands, and I'm going to tell you some evidence for a young solar system and a recent flood. It will be two parts in this presentation, and first I'm going for the evidence for recent creation. Let's focus on the magnetic field first. Well, as you all know, the Earth has a magnetic field, and it was Carl Friedrich Gauss who measured the magnetic field first in 1830. And ever since we have measured the magnetic field, it seems to decay with 5% per year. No, per century, sorry. There's another scientist, his name is Barnes, and he calculated in reverse how strong the magnetic field should have been in the past. Based on the fact that it decays 5% per year, and he says per century, and he says the Earth's core has an average electrical conductivity of 40,000 Siemens. That's some kind of unit. And that's consistent with laboratory experiments. And the fact is that the Earth's magnetic field can only decrease, it cannot increase. When you reverse calculate it, you can see that the magnetic field should have been so powerful only some 30,000 years ago that the entire Earth would have been molten by now, back then. And obviously it isn't, so there seems to be evidence for a young Earth. And it can definitely not be millions of years old. Other scientists do, in fact, have a theory to try to explain that the Earth it works like a dynamo, so that it can maintain its magnetic field for much longer. And that it's kept active for billions of years like a dynamo as we have in our own equipment. But the point is, a dynamo is not such a simple device. You need to put everything in the right place and put energy in it to make it work. And the Earth's core just does not have these properties. So 100 years of experiments has been done, and no effective experiment has been performed in the entire century. This is one example I have here from, I think, 2006. Yes. It says in the paper, multiple runs of data were required in the 2005-2006 time frame. While the quality of the data appears to be good, no single clear message has emerged from the analysis. A dynamo was not produced. So the Earth interior is not capable of sustaining a magnetic field for very long. And this is just one random example. If you look for experiments, you will see this result all the time. There are some computer simulations that do match data. Paleomagnetic data is called. It's magnetic data that has been recorded in rocks. But those simulations, they do not match experiments. They just assume that the dynamo theory works. So this is an article. I'm only going to read the parts that have marked yellow. It says that it would imply a young Earth. So they do admit it implies a young Earth, but they assume billions of years. So they do not accept this. But they say for a few brief weeks, researchers thought the mystery might be solved. In recent months, however, actual experiments using diamonds and lasers recreate the intense conditions of the planet's core raise doubts that the paradox will be resolved so easily. So they keep having problems with this theory all the time. Now there is this creationist, Dr. Russell Humphreys. He had made a theory in 1983 about well, he says, what if this magnetic field has something to do with creation? And then he figured that the Bible says that the earth is made of water originally, and if you do, then you can actually calculate if all these molecules are aligned in a specific way. It's a bit complex, but then there would be a magnetic flux at the beginning, and the earth just holds that magnetic flux and decays throughout the centuries that follow. And based on that, he could calculate the magnetic fields for all planets in the solar system. And he also looked at magnetic reversals that has been recorded in the rocks. And he says that magnetic reversals probably happened during the flood, and that accelerated this decay a little bit, so the time span is even a bit shorter. Because when you have two polarities, opposite to each other, it will consume some of the energy. Well, he predicted the strength of the magnetic field for 6 planets that had not been yet measured yet, and 5 out of 6 of these predictions matches exactly what he calculated. Only Pluto still isn't measured, even not by the New Horizons satellite that got there last year. So we don't know anything about its magnetic field. And basically, on billions of years, Mercury just should not have a magnetic field, but it does. And it also should not have a liquid core after billions of years, but it does. So, and Dr. Russell Humphreys was the only scientist who made correct predictions about all the magnetic field. So, actually, creation scientists do have very large successes in some cases. Next, we have moons on other planets. Here is Europa, Enceladus and Ariel. They have specific properties, and what we see here, especially with Enceladus, is water eruptions. For water to erupt, you must have a specific temperature that's not far below freezing. So these moons are still a bit warm, and if you calculate that they could not be this warm for billions of years. Also, scientists try to explain this by tidal effects because of the plane of the moon orbiting the planet, or radioactive processes or chemical processes. But some of these moons are just like our moon, constantly facing the Earth, the planet with the same side. So there are no tidal effects on these moons. There are not enough heavy materials to be radioactive materials there. And chemicals, well, you have to have very exotic chemicals to get that amount of heat, and that's also very unlikely to have those chemicals on those moons. So the total of these 3 explanations only got even less than 10% of the heat of these moons, and experts call the heat of these moons mysterious. But this, if these moons are young, then they just did not have enough time to cool down yet. Pluto was the same problem actually when the New Horizons satellite flew by last year. It was a big surprise because Pluto is geologically active, and it's supposed not to be. Also, its moon is geologically active, so they calculated the upper limit of the age of Pluto's surface, and it could not be older than 100 million years old. Well, it's supposed to be 4.5 billion years old, so no, that's a lot more. Tidal effects, you don't have them on Pluto because it does not orbit another planet. So it's even more problem for them than the other moons. Now we have also comets here in our solar system. These comets all have an interstellar origin, an elliptical orbit. What we mean by that is that they all repeatedly pass the sun. They do not come in from outside and then go out of the solar system again. No, they are inside the solar system. Thus repeatedly they will pass the sun. Every time they do, they have this nice tail that you see on the back. And that means they are losing material every time they pass the sun. And this comet Halley has an orbit of about 200 years. Well, it should have been gone by now. It cannot be that old. Also, there's this nice movie that they made to visualize planet formation. What they say is a star used to explode, and then we have a cloud of gas, and that cloud of gas is because of gravity attracting it into planets slowly. This is not a simulation, this is an animation. So you see here a tiny planet growing out of a gas cloud. That's how they say planets formed. Star explodes, dust cloud, you would have dust clumping together into grains, grains clumping together into rocks by gravity, then rocks to boulders, boulders to asteroids, asteroids to planetoids, planetoids to planets. But the problem is, when they get to this stage of grains and rocks, they still do not have very much mass to attract. They do not have much gravitational, there's no mass there. So there is more likely they will just collide with enormous speed and explode back into dust. Simulations show this, that they do not clump together into planetoids. There is a threshold here that they do not pass. So this theory doesn't work. There's also, we have Saturn's rings. And what they see about these rings is that there's more structure than they expected, and they also change fast. They are growing in size and moving a little, and also they are losing material. They are dissipating. Sorry, English is not my native language. So they're slowly dying, these rings. So those can also not be old. Then we have radioactive decay. Well, this is the strongest argument for the opposition to go for an old solar system, actually. But there is something wrong. I'm going to show 3 examples. There are more, but I chose 3 of them. Flattened radio halos, helium diffusion, and how good does it match geological dating anyway? Well, flattened radio halos, what are radio halos? Well, you have this radioactive material in the middle. Here this is radioactive thing. When it radiates, it has a specific amount of energy, causing particles to be thrown out. And they end somewhere else in the rock. And because of the amount of energy, they can get to a specific range where they can damage the rock. And so based on this range, you can tell what kind of material it is. So as less powerful material will end up there, and more powerful material will end up there. So you get these nice halos that you can see radioactive decay did happen. It's strong evidence that it did happen. Some of these rings you can also find in codified wood, and these have been flattened. Now, if you have a few thousands of years of decay, you will have a faint ring. After millions of years, you get a more dense ring. And the longer it takes, the more black it will become. But these are flattened. Why? Well, because this coal is compressible, and at a certain point there will be layers on top, geological layers on top, and it causes pressure, so it will compress these radio halos. And these rings we see being elliptical, that's That's decay that happened before it was flattened. Afterwards, there will be more radioactive decay, forming a new halo around it. Then we see this layer is supposed to be millions of years based on the amount of decay that has happened here. But these layers are also dated millions of years on top of it. So the flattening event should have been millions of years ago. However, this decay of this radio halo around the circular radio halo is only a few thousand of years ago. So the flattening event based on these radio halos happened only a couple of thousand of years ago. So there's an inconsistency here. Now, one way to explain this inconsistency is that there used to have been accelerated decay, so very fast decay in the past, not in billions of years, but in a short time period. There's more. There's a RATE team. RATE is radioisotopes and the age of the Earth. A team of creation scientists who have investigated the problem that radioactive decay has with the creation model. And they have investigated zircons. Inside zircons, it's a tiny piece of crystal rock, there are uranium atoms which also have decayed. And when they decayed, they have released 8 helium atoms before they turn into lead, which is stable. Now, these zircons are found in drilling projects, which is very hot down there. Well, and there is still some helium inside. Well, what can we learn from it? If it's cold, the helium will leak out very slowly. If it's very hot, you will get this helium leaked out faster. You can measure this in the laboratory, and they actually did. But before they did, these scientists first made a prediction based on what they measured, and they say, well, if the creation model is correct, then it has to follow this upper line. And if the uniformitarian model is correct, then it has to follow this line below. This is not linear, this is a couple of orders of magnitudes higher. It's strongly non-linear. Well, the results came in from a laboratory that didn't know they were working for a creation group, and this is the result. It's bang on. Also, when you compare radiometric ages, dating methods, compared to geologic ages, you see that it does follow a line, more or less. So when it's 500 years old dated, this is the dating age, this is the geological age, it does kind of follow the line, but there's also a lot of spreading away from this line. So some layers that should be 200 million years old date 3 billion years old, and also the layers that are supposed to be 500 million years old just date less than 100 million years old. So there is something wrong, and it could be, we can say there has been billions of years worth of decay, but it probably happens faster. And there's no sound explanation for it, unfortunately. So my conclusion about the solar system, there is only one argument that's kind of strong for an old solar system, but many more that are actually pointing to a young solar system. They're really not reading it from the evidence that they find on planets and moons. And even the radioactive decay, well, there's enough evidence to assume that it happened fast. Then we're going to look for a recent flood throughout the solar system. First, we'll take a look at the moon. This is a movie that NASA created to show what happened in the past to shape the moon's surface. It's called The Evolution of the Moon. Well, of course, NASA assumes that the moon has formed from rocks that accumulated, we've discussed it earlier. So they say 4.5 billion years ago, the moon looked like this, with a smooth surface. Yeah, well, I think the moon was created like this before cratering happened. And they say at the South Pole there is a large crater called the Aitken Basin, and they say it happened 4.3 billion years ago. And afterwards there were some large impacts over here. I actually like this movie. I don't agree with the time, but I like the movie, the way it is displayed. They say this is 4.1 billion years ago. And then afterwards we have volcanism. So they say this was volcanoes for more than 2 billion years. It has been volcanic like this. I get back to that. And then next there are the smaller crater events happening. It's already beginning to look like the moon as we know it today. And they say also 3.8 to 1 billion years ago, smaller impacts happened. And quite a lot also. Okay, and then we have the moon as we see it through our telescopes today. Okay, so first formation, then the South Pole, then the large craters, then the volcanism, and the small craters. That's the sequence. Now let's take a look at these maars. This is Mare Imbrium, and this is the largest mare, Oceanus Procellarum. This is a height map of the moon, so it's not the real color. Green means higher than blue, but it shows it in more detail. Here we see these large craters, and the Oceanus Procellarum actually is not a crater. If you zoom into it, you will see that these two craters are actually connected by a lava flow. I don't know if it's clearly visible on the screens there. And also over here there has been a lava flow flowing from the crater to this, causing this Oceanus Procellarum. Next, there are also these two craters seem to be connected by lava flow. That happened in the past. Yeah, but I think if they are connected, then these impacts must have happened nearly simultaneously. That's my interpretation. There's something so stronger. If we take a closer look to this largest crater over here, then we see that there are also smaller craters in there. And I think the sequence should be that this large yellow, what I'm marked yellow is the first one, this smaller one is the second one, and the third are these ones I marked purple. Why? Well, basically because if this yellow crater would have been second, it would have wiped out this smaller crater. So you can tell the sequence. And also, this crater was filled with lava that flowed from this thing, so this crater was very soon after this large crater. And these purple ones happened after the backfilling of the lava, after the lava solidified. I think the lava came from the impacts immediately because it causes a lot of heat. So the intervals must be weeks at most. If we even exaggerate this height map further, we can see more details. Because there are also two faint craters in here. And when you see it from the side, you can see it a bit more clearly over here. And there's this straight line that they are connected. So when you think of these two craters, which of these two should have been first? Well, I think they must have been exactly simultaneously, because otherwise one of these would be round. So is this the first, or is this the first? Well, I think this one happened first, and this one impacted the molten lava. So we have these, this large crater that initiated the lava flow, the second crater that was happening soon afterwards, then lava backfilling, then the red ones happened, then the lava solidified, and then we have these smaller purple craters. And these all happened within weeks, months, maybe. A lot of impacts happening altogether. Oh yes, and those red, the ones I marked red, are called ghost craters. Now, this is also described on the website creation.com. It's one of the 101 evidences for a young Earth. Well, long sentence. If you read it, this is basically the same as what I said about these ghost craters. In a very narrow time frame and cratering occurred quite quickly. Well, let's take some objection from a very anti-creation page to show what their objection actually is. They say this description of ghost crater formation is a strong and oversimplified to the point of incorrectness. The Mare formation eruptions are known to have occurred millions of years after the impacts, based on radiogenic dating of the volcanic basalt and the pre-Mare ejecta. Chemical differentiation and layering observed in Hadley Rill shows that the Maria were formed from episodes of volcanism extending over geologic time, not in a single event. Well, that's what they say. I'm going to repeat it. So they say basically the lava flow is not related to the impact. So you have a lot of heat generated, then it's solidified, and later it erupts again. No. How you are supposed to do that, and also I don't know how then this lava flow reaches up all the way thousands of kilometers on the surface of the moon. Okay, but they say that. They say the lava flow was millions of years after the impact. And they say there were multiple lava flows, so I can't read that from the evidence I've seen here. Okay, and then they say ghost craters are oversimplified. What are they then? They are not saying what they are. I wonder if they even have seen it this way, knowing what they are talking about. Then they say the evidence is radiometric dating and there's layering. Well, this layering is, they say there are multiple layers of different chemical compositions on top of each other. So they say then the first eruption caused material A, and then the next eruption caused material B. Why? Why couldn't it just have been thrown out all at once and then demixed because of density differences or solidification differences or something? We also see different layers at Mount St. Helens on Earth, which also happened at once. So there's no good reason to say different layers is different times. So I'm going to wipe out that argument. Now radiometric dating, well, we've seen that, and that probably was accelerated. So I'm going to wipe out that. So there's no argument actually that still stands, in my opinion. Let's take a look at secondary impacts. This is the back side of the moon. We never get to see this. It's always the same side we see. And this is the back side, this is the south side of the moon. And what we see over here, this is the same crater that's seen from below, that's seen from behind. That's the Aitken Basin. And they say that is the oldest crater. Could be, I'm not sure if it's a crater. But there's also on the west side of the moon, there's this very nasty crater, which is very clear. And we can also see some craters inside this Oceanus Procellarum. But we see these have been backfilled. And we see only a few craters here and much more over there. And what we saw in the movie was that first the volcanism happened, and then the small craters. But if that would be the case, then there would be just as many craters here as there would be here. They're not there, so I think the sequence is not correct. Okay, let's take a closer look at this crater. There are a lot of features on the moon that seem to be related to this single crater. If you look here very closely, you get these stripes over here, a gap over here, and some pathways over here. And what I think to see is that sometimes smaller craters are here and then a large one over there. And like here, you have this pathway, and then a large crater over there. So I think one impact exploded, causes a lot of rocks to be thrown out, and then impacted somewhere else on the moon again. So there were less impacts than we see here, less primary impacts. Yeah, you get a closer look, you see these paths, small craters, all pointing to that single one. And it extends, well, almost a quarter of the radius of the moon. So let's take a look at it again. Well, formation, we know that we've seen that before. The planet formation theory doesn't work. And the South Pole Aitken basin, well, theoretically could have happened somewhere in the distant past, theoretically. But this basin formation, well, it couldn't have happened over such a large time span because the craters are connected. The volcanism couldn't have lasted for so long because it emits a lot of energy and will cool down very quickly. If you want to know how fast, you will have to see my next presentation. But millions of years, definitely not. Then we have this intermediate cratering. No, they were not billions of years after the other cratering. They were almost simultaneously. So we see this very large catastrophe that hit the moon. Let's take a look at Mars. We also see a crater over there, and also a very strange crater in this case, because this crater, this is a part and this is a part of a crater. And what it seems to be the case here is that there, before we knew this, there was thought that only the Earth had moving plates and earthquakes and tectonics. But there seems to be a little bit of tectonics going on Mars as well. Only 150 kilometers, not 6,000 or more as we have on Earth. But here, what I think to see is that we have this impact here that seems to be related to the cracking of the crust of Mars. There's also, I think this is some kind of cracks that seem to have something to do with an explosion, just rupturing the crust of Mars. There's also evidence for a flood on Mars. When you take a look at Mars' surface, you see these patterns that are strongly related with the water flow that has been there. And actually, scientists do agree that Mars used to have a very large flood period. They do accept that for Mars, but not for Earth. Okay, and I think when we take a look at the moon, this one side has had a different history than this side. It looks very different. So there seems to be a large crater on one side and smaller craters on the other. This is also very strange. So yeah, very large difference between these two sides. You can see it very closely here. When we look at Mars, we also have a difference. On the south side, there are much more craters than there are on the north side. And when we take a look at the north side, there is a very rare shaped crater that's not round. If a crater is not round, it means the impact was extremely shallow. Less than 15 degrees angle. And that crater happens to be on the north side, not on the south side where it happens so much. So it came from the south and almost missed Mars. So all craters seem to point to a bombardment on one side of the planet. When we take a look at other moons, they show similar patterns, more craters here than there. This one is of Saturn, we see more craters here than there. Almost no impact there. And in this case I think I can say that we can be sure that it's not because of wiping out craters, because some people say Mars, the craters on the north have just been wiped out. Could be, but I think that's not the case for this moon. It doesn't look like that. How about the Earth then? Well, some people do believe the Earth didn't look like it looks now. There used to be some kind of supercontinent on one place, and this is South America, and this is Africa, and it used to rupture into continents. But if you join them together, you can see that almost half the Earth is covered in continents and the other half is not. And I think if you assume a large meteorite bombardment with lava flowing from it, this is made of basalt, and the ocean crust is also made of basalt. It's the same material, also looking like it came from volcanoes, volcanic activity. So I think this side of the Earth did get very large impacts, and this side hardly got impacted, but only small craters. And I think this is one very large catastrophic event that affected the entire solar system. So I think the Fermatorian model is incorrect. The interpretations of impact sequences on the moon is refuted by the evidence. The moon has strong evidence for a large bombardment over a short time span, and many celestial bodies in the solar system show one-side bombardment, which implies a short time span of a catastrophic event. There is evidence for a large flood on Mars, and the implication for the Earth is, well, in this bombardment, if the entire solar system got bombarded, the Earth could not have been missed. I didn't tell that, but the impact chance on the Earth is 19 times larger than on the Moon. So, now calculate how many craters we should have here. The Earth's ocean floor is made of basalt. On the Moon, basalt flows are strongly associated with large impact basins, so I think it's the same for the Earth. The evidence of the Earth also fits a single one-sided bombardment, and the entire solar system was involved in the Genesis flood. That's the end of my first presentation. So, if you have any questions, I would like to answer.